So I guess all we do is just review a bit. Do y'all have any specific questions? All right. If I ask you what's the reaction quotient here, you could write you could do that just to write the reaction quotient. All right, what about this one? If I wanted to do this one, I've got a 2 there, so I'm going to do that. Is that right for that one?
Wouldn't the H2O not go in there?
Yes. Is that right for that one? It's not right because I included the H2O, which is a liquid. So you only want to include the gases and the ones that say aqueous. Not liquid and not solid. So I should not have put that there, but if I erase it, that's correct, right? I picked out a few of these that had solids. So these won't go in the reaction quotient. Those won't. I think this was gas. So let me go on to the next subject. You're told Kc equals 17. You're told to calculate the reaction quotient and then state which direction it's going to get back to equilibrium. Reaction quotient is this. So if this is the concentration, 1 for N2, 1 for H2. Cubed, cubed.
The Larmon would be the second house.
Squared. So what is 0.2 squared? 0.04. That's right, isn't it? 0.2 times 0.2?
It's
0.04. Make sure my brain's working. 0.04. So, I'll go ahead and do the math. 1 divided by 0.04, 25. So that means this is where a number line for Q, and right here is K, which is 17. And we're at 25, that means it's going this way to get back to 17. That means it's got to get smaller. This has to reach a smaller value. So which way is it going, left or right, to get to a smaller value? going to the left. Everybody get that?
When you divide by zero, for like the bond, the reactants.
Yeah, there was one in there that had divide by zero, and that ends up giving you infinity.
So that when you shift to the left, it's the.
So then it would be going down from infinity. We might get through these quick. No specific questions?
Can we go back to the last?
Conjugates and the proteins. I'll get to it. This is that same reaction backwards. For this one, you need you're given Kc equals 0.5. Temp equals 400 degrees C. The R value we have to use here is 206. Do you remember how to get delta N? Make sure you're only looking at gases. You have 3 moles of gas here and 1 mole here. So 4 moles of gases here, 2 moles of gas here. And you go final minus initial. So 4 minus 2 equals positive 2. Temperature. 37. And this is squared. In this case, we're given Kc, we have to calculate Kp. Kc is 0.50 times all of that is Kp. Let's see if I can do it. 673 times 0.08216. So, what do I have for answers there? KC, well, I did it wrong. Did I just go too fast?
No, I think you flipped up this, because you did 4 minus 2, it's supposed to be 2 minus 4, which would be 2.
Final.
Because this one should be, this is the problem, this is the
Oh, that's right.
So you flipped them backwards.
So if that was 10 to the negative 2, would I have gotten the right answer? Okay, so this was backwards. Thank you. Trying to go too fast. All right, in which case it's final minus initial. 2 minus 4 is negative 2. Which means 1 over. Does that get closer to the right answer? 3 over 4 9 times 0.5 6. Is that the right answer? Y'all good with these? It's just applying that formula. how to get the delta N.
You solve for KC.
Oh, yeah. P. Okay, this is going to be, see that, 1. This is that weird hydrate. Na2SO4. That's 10 H2O's on it. And this one is a solid. That one is a solid. I don't know if I've said this before, but if everything is a solid or a liquid and there's no gases, then Kc equals Kp. They just end up the same. Or maybe Kp is undefined. I'm more comfortable saying it's undefined. If Kp equals times 293.
298.
It's going to be 0 gas over here, 10 moles of gas here. This has to be in the 10th power. Holy crap. The way I do this, it's not too bad. 0.08206 times 298. The 10th power, what am I saying? What was the answer to this?
Should be 3.3 times 10 to the negative 20.
To the negative 20?
Yeah, 10 5. So it should be 5.
The 10th power. How did you solve that? I must have done this in a spreadsheet. Can't imagine doing one like that on the test. I guess there is a button on a calculator where you can calculate that, but there's no reason for me to go that crazy. Want me to solve another one? Maybe this one I'll solve it.
No, it's okay.
Okay. There's a reasonable Kp value. And it's to the first power. That's a better one. Temperature, predict direction. You want to do these? We went over these Friday.
Did you do
Yeah,
like
we do
decrease
these.
and increase? Like with decreasing and increasing?
Review. heat's too low. Heat's 2. Gas. It's gas as well. What are we doing? Delta H equals 484 kilojoules. The other day, you said positive products. That's not right. It's the opposite of that.
It was right on the quiz though.
Well, let's go through these. It depends on, no, it depends on how you think about it. But if this is positive, that means it's like heat went in as an ingredient.
But then when
If it's negative, it's like it comes out. So you write it over there, huh?
but if you add these to the reactants, wouldn't it move to the products?
Well, if this is positive, you write heat over here, and now you look at the questions and see whether it's saying increase or decrease. If you increase temperature, it'll shift that way. If you decrease temperature, it'll shift this way. You with
But
me?
positive products still works though. Because if you have an increase in temperature, that's positive. If you
Well,
have delta H, that's positive. It would
You
be
go with what works for you. All right. But if these are the products, and that makes me want to write heat over here, positive products, but that's wrong.
Okay.
Because if you do write the product here, then when you increase temperature, it goes this way instead. And when decrease temperature goes this way, so it does change the answer. But if you're getting the right answer, however you're doing it
Okay.
with your mnemonic. I went along with your mnemonic Friday, and then I
I
changed
think
it.
I was using the mnemonic and thinking about it differently than you were.
Yeah, okay. So positive, it goes with reactants. Negative, it goes with products. Okay, but I asked increase in all of these. But increase just means increase, it shifts that way. If I asked decrease, then that would mean heat came out and it shifts this way. You guys okay with that? Let me do one that's negative, just to be complete. Whatever. So if it's negative, nothing else matters here. So if that's negative, then I would write heat over here. Now, increasing temperature shifts towards products. Decreasing temperature shifts towards reactants. What the actual reaction here doesn't matter. This is what matters to whether it shifts one way or another. We don't have to look at gases here. You guys okay with this? I'm going kind of quick, but I feel like
So you're saying you're saying that if there was an increase in temperature, it would move towards the reactants for that one? And
Yes.
if increase in temperature would go to the products?
Or I wrote product and reactant wrong, but this is the reactant, and this is the product. Okay, I put heat on the right side of the product because that's negative. So now increase the temperature, we shift towards reactants. Decrease the temperature, we shift towards products. Oh, I'm going too fast. Going too fast for me anymore. Pressure, predict direction. This one. O3 and 2, and delta H here is negative 2 and 5. It's negative, so which side do I want to write the heat on?
Go right side.
Huh?
Are they right side?
On the right side, but you know what? This is about pressure, not temperatures. So this is a red herring, really.
So do you need to look at that for when you're looking at pressure?
For pressure, no, you don't need to look at that at all.
So just ignore that?
Yep. It's a red herring if I'm asking about pressure. So how many moles of gas are on the left side?
Oh, wait, 2.
2 moles. How many over here?
3.
All right. So if I increase pressure, which way does it shift? To the left. If I decrease pressure, which way does it shift? Right. Let me ask you this. The equilibrium shifts, the K shifts. If this is Q, and here I am at equilibrium, I haven't given you any equilibrium values. But let's say I increase pressure. And that's K right now. I increase pressure, do I get a new K up here or a new K down here? Huh? So if I increase pressure, it shifts this way. That means my numerator and denominator. Oh, well, I'll say products. I increase pressure, it shifts this way. The reactants increase and the products decrease. So which K am I getting for a new K? Am I increasing or am I decreasing? When I increase pressure? Decreasing. If we're shifting this way, reactants are getting bigger while products are getting smaller. So that'll make my K shift bigger. Does that make sense? I meant to put something like that in there. If you can decide whether it's shifting left and right, then you can use this basic logic to decide whether the K is going down or up. When you change temperature and change pressure, you literally change the new K. There's a new equilibrium. So you understand this much. I got more moles of gas over here and less over here. So if I increase temperature, it's going to shift this way. If it shifts this way, that means I'm getting less of this and more of this. So that means this is getting bigger while this is getting smaller. Yeah. I mean, like 4/10. If I want this to get bigger and this to get smaller, let's say that turns into a 2 and that turns into 15. This is smaller than that.
So
If I make this bigger and this smaller, this ends up being a.
So when you increase pressure, K goes down.
In this case, because there were more moles of gas here and I was shifting left, making reactants bigger and products smaller.
What if the products were bigger?
Let me make it even bigger. I want my 10 to be bigger and my 4 to be smaller. Let's say my 10 goes all the way to 150 and my 4 goes all the way down to 1. Which one of those is bigger? 150 is tiny compared to 4/10.
It's going to be on the test.
Well, that's why I'm going over it. You want me to put more questions on there to reflect this? Is it too late? Put it on the test. It's too late. There's one more step of logic here. If we're shifting this way, this is getting smaller and this is getting bigger. Which means this is getting smaller. Yeah, this is getting smaller and this is getting bigger. Which means this is getting bigger and this is getting smaller. Yeah, I want to ask some of those, but I think it's too late. I wasted last Friday, so. I'll ask that on test 3. Student overviews. Did y'all understand what I was saying there? Solid. Gas. And the next one's solid. Okay. How many moles of gas are on this side? Oh, what did I say? Did I say solid? How many moles of gas are on this side? Zero. 0 moles of gas. How many over here?
1 mole.
So if I increase pressure, which way is it going?
The right.
To the right. Because it compress into a smaller space. If I decrease pressure, it'll shift left because it's got more space to expand into. And I could also say if I decrease the volume, that's like saying the pressure goes up, which would make it go that way. Increase the volume, it'll shift this way. You okay with that? Increase the volume, increases. Increase the volume, it decreases the pressure.
Is that new to K?
Huh?
No, this is with pressure.
Well,
I'm
the
not-
pressure makes sense, but like not K.
Okay, but forget K, what about volume? If I increase the volume, is that going to increase pressure or decrease pressure?
Decrease pressure.
Hmm?
Decrease pressure.
Increase volume, decrease pressure. Or increase pressure. Alright,
If on both sides, if 1 mole and 1 mole, that would be no change.
no change, exactly. If it's the same moles of gas on both sides, changing pressure won't change the equilibrium. I'll save it for testing. Too late to start throwing things around. That's what I get for laying down flag. Just making test 3 there. Maybe one of these for A. You got to do those ice tables on test 3, which brings all these chapters back. Yes. So if I increase this, how do the concentrations change? So if I suddenly increase this, which way does it flow? To the right. Which means this will increase and this will decrease. That makes sense? If we're shifting from left to right, we're going to get more of that and less of this. This, since we increased it a little bit to begin with, it'll remain just a little bit higher than it was to begin with. This one increases just a little bit. But this one will decrease and this one will increase. Make sense? increase that when things get back to equilibrium, will this have increased or decreased? Increase. If I increase this, we're going to shift that way. So this will increase, and this will remain just a little bit increased from where it was.
Wouldn't, the N2 decrease?
Say it again.
The N2, wouldn't that decrease? Is this number 5?
All right, that one is increase the O2. Number 5 is saying we increase those, then everything goes back to equilibrium. So comparatively what they are. So which way is it going to shift if we increase this one? To the right. So this one will be increased once we get back to equilibrium. This one will decrease because we have to use that up to go that way. And this one will remain a little bit increased from our original increase. The flip side is, what if I decrease this? What happens when we get back to equilibrium? If I decrease that, which way does it shift? To the left. If you add some stuff, it shifts away from it. If you remove some stuff, it shifts towards it. So it's going to shift to the left towards it. So there will be less of that, more of that. And since I decrease this, it will be a little bit decreased than it was to begin with. You guys okay with those? Okay with that? Calculate the equilibrium constant. This is kind of plug and check. So it's saying here's the equilibrium concentration. Find one. Oh, that's got coefficients. Let's do that one. Into 3H2. NH3 is 1412. Gases. Concentration of N2. And it's plug and chug. NH3 was 0.412. And just calculate that. Four 1.2 times 412. She's not there. What did I do wrong? 0.06. 0, 0. I'm so spoiled with spreadsheets, it's pathetic. Yeah, that's not right. That's what I got for the denominator down here. Second time through. Think I'm passing the test. Y'all can do these right, it's just pleasure. Okay. Conjugate acids and bases. So the conjugate acid of this molecule, OH, if you're looking for a conjugate acid, you treat it like a base. Maybe you could just see into it, but technically what you're doing is, and that would be the conjugate acid. So what do you get here?
H2O.
So if that's a base, here's the acid, H2O. The opposite is, you're told, there's your acid, tell me what the conjugate base is. And you're filling that in. So you take off an H plus, of course this one's going to be OH. What's the conjugate acid here?
Number 2 for the H2O, you simply take H3O plus. So like,
Oh, it's asking for the conjugate acid. H2O. That's the conjugate base. If you want the conjugate acid, so if you want the conjugate acid over here, you add H plus on this side. That's the conjugate acid. What's number 3 asking? It wants the conjugate acid. So you add H plus. This is negative and this is positive, so make sure you do H2, CO3, and you get the neutral. You okay with that? Still going too fast. So that one should be H2CO. Right? Conjugate acid and then H3. And H4 plus. I do conjugate bases on the next one. H2CO3. That's not right. Fix that. H2CO. Did I just click the wrong one? H2CO3, that's what it should be. I must have clicked that one. I must have clicked wrong. I'm still going too fast. Bases. conjugate base of OH negative? It's just an oxygen molecule in its ion. What's the conjugate base in number 5? Conjugate base is where you remove an H plus, so it's going to be SO2 negative. What's conjugate base of number 7? S2 negative. Next quiz. Number 4. If you thought of this as A, B, C, D, and E. OH negative compared to H2O. Which one is an acid and which one is the base? Which one is the base and which one is the acid? H2O is the acid, OH is the base. The acid has an extra H. The only difference between these two is the presence or absence of an H plus. So this is the acid, this is the base. These two, presence and absence of the H plus. This one has the H plus, so it's the acid. This one is the base. It's missing the H plus. Right? You guys get that? Is it going to be an easy test? I feel like it's going to be an easy test, but I always think that. I've been teaching this for a long time. Also notice, you should have an acid and a base on this side, and an acid and a base on this side. The rest is reading through this. So H2SO4 is the acid, so it's A, B, or D. Its conjugate base is SO4 2 negative. So it's A or B. OH is the base, H2O is the acid, so this one's A. I don't need these weird hydrates. There's just no reason to make it more complicated than it is. Look at question number 7. You've got H2S on the left and HS on the right. So the HS minus is missing an H compared to the H2S. So H2S is the acid, HS negative is the base. NH2 negative compared to NH3. NH3 has the extra H on it, so that's the acid. NH2 minus is the base. So this one should read H2S is the acid, its conjugated base is H2S, so it's A or D. And base on the left side Protics. Wait for her. She wanted to do these. Okay, amphiprotics. If it's amphiprotic, it at least has to have an H plus that you can add to it. I mean, an H plus that you can remove from it. NH3 can accept an H, so it can be NH4 and it can be NH2 minus. So this one is amphiprotic. Behaving as an acid, it gains an H plus and becomes NH4 plus. As a base, it loses an H and becomes NH2 minus and H2. So that's the answer. You good with that? She just can't keep on. You understand these? You sure? I thought it was you that wanted to go over it. Is HPO4? Oh, it was? Sorry, you go back to sleep. You go back to sleep.
I don't understand that NH4 that like there's a question that has NH4 and then just like wasn't working together.
Okay. NH3 is amphiprotic. NH4 is that one who's down here?
Yes.
This one can't gain another H plus. That's because here's NH3. It's got that pair of electrons there. So an H plus can come along, and then that pair of electrons makes the bond, and that's how you get NH4 plus. But there's no more pairs of electrons.
Would you recommend us drawing the root structures?
Yeah, if you need to decide whether it can accept an H plus, you got to find a pair of electrons. Here's how oxygen does it. There's H2O. You can have an H plus come in here and get that. H3O plus.
Oh, okay, thank you.
There actually is such thing as H4O plus 2, but I won't ask you that in the test. NH4 was kind of pushing it. What about this one?
No.
That one can't be because there's no H's together. This one can become OH and it can become H3O. Just like that. This one can go from H2PO4 minus to HPO4 2 minus. So it can give up an H plus. It can also gain an H plus. You see this negative, that tells you it can gain another H plus to become neutral. You guys okay with this? Is it going to be easy? It is? It is. It's going to be easy. We got to do ice tables on the next test. And I just petered out on making more questions on here, so I got lucky, I got too tired of it. So where we go? We got to do Lewis acids and bases, couple equilibria, a little on thermodynamics. And I have to see if we have to get to electrochemistry. But I think that's it. It's creeping up on the end here. I think we're okay in terms of information I'm supposed to put Michelle in this class. But I stumbled all over kinetics for a few weeks, so that hung us up a lot.
Is lab 6 going to be on Friday or going to be next week?
I'm not going to do lab 6 this week. I think we can do it next week, so next Wednesday. What is lab 6?